Welcome to our journey into the world of blockchain. Today, we will deep dive into blockchain architecture. We're going to take you from the basics to advanced concepts, ensuring that by the end of this video, you'll have a comprehensive understanding of how blockchain works and its transformative power in various industries. Blockchain structure. Here we see the fundamental structure of a blockchain. Each block is like a digital container that holds transaction data. Notice how each block connects to the next through cryptographic hashes. These are unique digital fingerprints. The Genesis block is where it all begins, the very first block in any blockchain. From there, each subsequent block references the previous one, creating an unbreakable chain. If someone tries to alter data in an old block, the hash changes, breaking the chain and alerting the entire network to tampering. This linking mechanism is what makes blockchain immutable. Once data is recorded, it becomes virtually impossible to change. Block internal structure. Let's look inside a single block to understand its architecture. Every block has two main parts: the header and the transaction data. The block header is like the block's identification card. It contains the previous block hash. This is what creates the chain connection. The Merkle root is a mathematical summary of all transactions in the block, making it easy to verify data integrity. The timestamp records exactly when the block was created, while the difficulty target shows how hard it was to mine this block. The nonce, which stands for number used once, is the magic number that miners search for to solve the cryptographic puzzle. Below the header, we have the transaction list. This is where the actual value transfers and smart contract executions are recorded. This structure ensures every piece of information has its place and purpose. Network architecture blockchain operates on a peer-to-peer network. Imagine thousands of computers worldwide, all maintaining the same ledger. Let me explain the different types of nodes you'll encounter. Full nodes are the backbone of the network. They store the complete blockchain history and validate every single transaction. Think of them as the security guards of the blockchain world. Mining nodes are the workers. They compete to solve complex mathematical puzzles to earn the right to add the next block. Light nodes are mobile-friendly versions that only store block headers, making them perfect for smartphones and tablets. Wallet nodes provide user interfaces. They're what most people interact with to send and receive cryptocurrency. All these nodes communicate constantly, sharing information and maintaining consensus. This decentralized architecture means no single point of failure. If some nodes go offline, the network continues operating seamlessly. Transaction lifecycle. Every blockchain transaction follows a precise 5-step journey from creation to confirmation. Let's follow a transaction through its complete lifecycle. Step 1. Transaction creation. A user initiates a transfer using their digital wallet, which creates a transaction message signed with their private key. This signature proves ownership without revealing sensitive information. Step 2. Broadcasting. The transaction spreads across the network like ripples in a pond. Each node receives the transaction and forwards it to its neighbors, ensuring network-wide distribution within seconds. Step 3. Validation. Network nodes verify the transaction's authenticity. They check digital signatures, confirm account balances, and ensure the transaction follows network rules. Invalid transactions are rejected immediately. Step 4. Mining and consensus. Validated transactions wait in the memory pool until miners select them for inclusion in the next block. Miners compete to solve cryptographic puzzles, with the winner earning the right to add their block to the chain. Step 5. Confirmation. Once a block is added and accepted by the network, the transaction is considered confirmed. Additional blocks built on top provide extra security. This is why exchanges often wait for multiple confirmations before crediting your account. Consensus mechanisms. Consensus mechanisms are the democratic processes that keep blockchain networks secure and synchronized. Let's compare the two most important approaches. Proof of work, used by Bitcoin, operates like a global mathematics competition. Miners use computational power to solve complex puzzles. The first to find the solution wins the right to add the next block and earns newly minted cryptocurrency as a reward. This system is incredibly secure because attacking the network would require controlling more computing power than all honest miners combined, an extremely expensive proposition. However, this security comes at an environmental cost due to high energy consumption. Proof of stake takes a different approach. Instead of computational competition, validators are chosen based on how much cryptocurrency they've staked as collateral. Think of it like a security deposit. Validators risk losing their stake if they attempt to cheat. Proof of stake uses 99% less energy than proof of work and can process transactions much faster. However, critics worry about wealth concentration. The richest validators have the most influence. Ethereum's recent transition from proof of work to proof of stake demonstrates how blockchain networks can evolve to become more sustainable while maintaining security. Security architecture blockchain security operates through multiple layered defenses, like a digital fortress, with many protective barriers. At the core, we have cryptographic functions, mathematical algorithms that create digital signatures and hash functions. These are virtually impossible to reverse engineer with current technology. The next layer is the immutable ledger itself. Once data is recorded and confirmed by the network, changing it would require rewriting all subsequent blocks, which becomes mathematically impossible as the chain grows. Digital signatures ensure only the rightful owner can spend their cryptocurrency. Even if someone intercepts your transaction, they can't forge your signature without your private key. Finally, network consensus provides the ultimate protection. Even if an attacker compromises some nodes, they'd need to control the majority of the entire network to successfully attack the system. This distributed security model makes blockchain one of the most secure technologies ever created. Layer architecture blockchain technology is built in layers, each serving a specific purpose in the overall system architecture. At the foundation, we have the network layer. This manages peer-to-peer communication, node discovery, and message propagation. It's like the postal system that ensures information reaches every participant in the network. Above that sits the data layer. This is where blocks, transactions, and cryptographic hashes live. Think of it as the filing system that organizes and stores all blockchain information in a tamper-proof format. The consensus layer handles the democratic process. It contains the rules and mechanisms that help the network agree on which transactions are valid and which blocks should be added to the chain. At the top, we have the application layer. This is what users actually interact with. Wallets, decentralized applications, smart contracts, and user interfaces all operate at this level. This layered approach allows developers to work at different levels of abstraction. Blockchain engineers focus on the lower layers for security and efficiency, while application developers build user-friendly experiences on top. It's similar to how web developers build websites without needing to understand internet infrastructure protocols. Now that you have a solid understanding of blockchain technology, please appreciate my initiative and don't forget to like, share, and subscribe if you found this video helpful. Your journey into the world of blockchain is just beginning. Let's explore together.